Hi, Griffin. It's great to see you. Thanks for being here today.
Thanks for having me.
So, before we dig into details about the tank weighing scale we're going to talk about, tell me what Mettler-Toledo does.
So Mettler-Toledo is like Rockwell themselves is a global company. So we produce sensors of all types, whether that's for high precision sort of laboratory type sensors, pH conductivity sensors, or what we're talking about today, which is the industrial side of weighing sensors.
And today we're talking about a specific product, the Mettler-Toledo IND360 MultiACM. Did I say that correctly?
Absolutely.
Okay. So, what is that? What does it do?
Yeah. So the IND360 is an automation weighing indicator. So that's a device that takes load cells as an input. It's going to amplify that signal. It's going to give you all sorts of weighing functions such as calibration, zeroing, tearing, customizable filters, all sorts of things like that. But really, it's designed for easy integration into an automation system and to provide fast updates. So it has AOPs, EDS files, add-on instructions, a faceplate, everything you'd want to integrate into a Rockwell PLC, for example. And it's sending those weight values as a floating point, so you don't have to do any extra conversions. So really everything to get into the PLC as quickly as possible, that's IND360. Now, MultiACM is a new scale type option for IND360. So previously from Mettler-Toledo, we've had two basic levels of load cells. Our base level is a standard analog load cells that most people are familiar with. That's what you'll see almost anywhere. So that's multiple load cells connected into a summing box, and they're going to produce a single signal. So that's one scale. But that can be a problem because that single signal can actually hide issues with individual load cells. Our next level up has been our smart load cells called power cell. That does the A to D conversion of the load cell itself and gives a lot of useful information about each load cell. MultiACM, what we're talking about today, actually fits nicely in the middle of those two. So it lets you use those analog load cells you're used to that you've been using for years, but still get useful data out of each individual load cell.
So, do users have to have a Mettler-Toledo load cell to use the multi-ACM?
I'd I'd love for them to use Mettler-Toledo load cells for everything. But that's not always possible. I understand that. So the multi-ACM actually works with existing analog load cells from any vendor. So if you think about it, depending on your application, depending on your environment, a good quality load cell can last potentially for decades. So to try to convince someone that they need to rip out a good piece of equipment that maybe still has a lot of lifetime left in it, that's really tough to do. So at the same time, though, companies are under a lot of pressure to get more data from their facilities. So leverage that data into making more efficient processes, less downtime, really push themselves forward. So multi-ACM lets you use those existing load cells you already have installed. So don't worry about lifting that heavy tank to replace the load cells. It's staying where it is. Just install the IND360, the corresponding junction box, and the home run cable. So for a small investment and replacing 3 easily accessible parts, you can get a lot more data out of individual load cells with a brownfield retrofit.
So, why is it beneficial to have individual load cell data?
So one of the major benefits is simply confirmation that all the load cells are still connected. So with a traditional analog system that most people are out there using, if a load cell cable gets damaged, so somebody runs over a cable with a forklift, it gets damaged in some way, which happens all the time in the field, most systems aren't going to be able to notify you there's a problem. So it's just that one summed signal, as I said before, coming back to the indicator. So one load cell gets damaged, now the weight value is just going to change, and it's going to change significantly. So now you can't trust the weight value, but you don't know there's a problem. So if there wasn't somebody watching that display and saw that jump happen, which most of the time there wouldn't be, you could be making bad batches over and over again until someone notices the problem. or you could overfill your tank and you could spill out potentially toxic chemicals or whatever material you're using. So it can really lead to a lot of safety issues if you don't know what's happening. With MultiACM, not only is the automation system flagged immediately that there's a problem, it'll actually tell you which load cell is the problem. So when the maintenance tech goes out to start troubleshooting, he doesn't need to spend extra time identifying where the issue is. He can get right to work. But along with that, you also are getting data from each load cell for the weight. So you can monitor the center of gravity. So if you're reading the weight of each load cell and you see that center of gravity is starting to shift from where it normally is, you can take action right away. So if you have a powder material in a tank, for example, it can potentially start to cake up on one side. If that's a problem for you and you need a roughly equal distribution, you can have that center of gravity trigger your PLC to turn on a device to redistribute the material in the tank.
And which type of users benefit most from this?
So as I see it, the biggest benefits are going to be for those users who are using tank scales for brownfield retrofits. So the standard IND360 has a tank and vessel application that monitors the weight and can perform an automatic refill if needed. But with MultiACM, that actually gets extended with a feature called LoadAdvisor. So this includes easy tank scale commissioning guidance, graphical center of gravity indication, and additional graphics showing where any problem load cells are physically located under the tank. So without LoadAdvisor, we can tell you load cell number 2 is the problem. With LoadAdvisor, we can tell you load cell number 2 is the problem, and it's located under the back right foot of the tank.
Now, I know that you have a LoadAdvisor that helps with tank scale commissioning. Can you talk about what kind of pain points that takes care of for the user?
Yeah, I mean, commissioning a tank scale, as you can imagine, is a stressful process. So you've got a multi-ton tank that you're putting on load cells. You want to get everything right the first time, whenever possible. So LoadAdvisor is going to help you with that. So it's giving you step-by-step guidance on what you should do to set up the tank scale and when you should do it, right? The order of these steps matters. So if you need to know when do I perform the calibration of this scale, LoadAdvisor can help you with that. But not only that, it has a few exclusive features to LoadAdvisor. So one of those we call fast shimming. So it's shimming guidance. So when you have a tank scale, you want to shim the legs so it's going to give you the best accuracy possible. So you've got a sort of level starting point. But if you're not familiar with this, if you don't have experience doing this, it can really be tough to tell if you need shims at all, and if so, where to place them. So this fast shimming will not only tell you which load cell should be shimmed, it'll tell you how thick that shim should be to place underneath that leg of the tank. So if you want to have the peace of mind that you're maximizing your chance to set up everything and set it up correctly the first time, that LoadAdvisor for MultiACM is really going to take you a long way.
And can you talk to me about how the MultiACM is a fit for brownfield retrofits as well as greenfield applications?
Yeah, I mean, so what I've described so far, MultiACM is definitely the best option for brownfield retrofits, right? It's small investment, getting more data. But when we talk about greenfield, MultiACM can work for that. Absolutely. It's going to give you all of this data I've talked about already. But when we talk about greenfield applications, I think of it as, basically a clean slate almost. So we're starting fresh. We don't have as many constraints on us. So it's helpful to take a step back and evaluate what's going to give you the best value, the best bang for your buck, and what's going to be the most useful going forward in the future. So with that, greenfield is really where you'd want to look at those smart power cell load cells I mentioned before. So they're going to give you all the information MultiACM is giving you, and then more on top of that. The fact that the A to D happens at the load cell gives you better noise immunity because we're sending back a voltage level signal instead of a millivolt level signal. And like I talked about before, cables get damaged and run over all the time in the field. It's great that MultiACM can tell you where that problem is and that it needs to be addressed. But with analog load cells that most people are using, the cables are integral to the load cell. So if that cable gets damaged, you have to replace the whole load cell. So you're lifting up the tank, you're pulling out the load cell, you're putting the new one in, you're recalibrating most of the time. It can give you a lot of downtime to deal with. With PowerCell, those are connected with an M12 connector. So that cable gets damaged, you go to the shelf, you grab a spare cable, you unplug the old one, plug in the new one, you're back up and running right away. So the downtime savings there alone is huge, but there's a lot more benefits I don't have time to talk about today, but I just wanted to highlight this one to show this is a product that is thoughtfully designed to deal with problems that are just inherent to traditional analog load cells.
Well, this is a lot of information that's useful and interesting, and unfortunately, we've run out of time. So I'll include links for more information in the episode show notes. Thank you so much for sharing this information with us today.
Thank you.
And listeners, thank you for joining us. Please consider sharing this episode with colleagues who would find it useful. And until next time, I'm Theresa Houck with the Journal, and we'll chat again soon.